Well, students, today I'm going to discuss a topic on separation and purification of substances from a mixture. I hope uh, you will get more interest to learn the videos, and by this process you will take preparation for your exam. Well, let me change the video now, change the slide now. At first, we need to understand the importance of purification. Suppose if you are taking a medicine, okay, that medicine is manufactured in the industry, no doubt, but if that medicine contains any undesirable substance in it, then it will be very much harmful for your health, right? Rather than curing your disease, it will be harmful for you. So that is why we must have to ensure whether it's any undesirable substances are available which we consume in our daily life as food or as medicine. It does not contain any kind of undesirable substances which is harmful for our health. Okay. Now, the question is how will we understand whether a substance contain pure or impure? Whenever it is impure, then the question comes if it contains any undesirable substances or not. So let's see some techniques by which we can understand a substance is pure or impure. For example, here for understanding the whether a solid is pure or impure, we can measure its melting point. If it melts exactly at its melting point, we know every solid substance have definite melting points, right? For example, ice melts at 0 degree. So if it exactly melts at its melting point, then we will understand it is pure. But if it melts at more than its melting point, then definitely some impurity is there. For example, here you can see that impure means it is a melting point of a pure substance, and T impure means it's the melting point of an impure substance. So by measuring temperature, we can predict whether it is pure or impure. The same thing for a liquid as well. If a liquid boils exactly at its boiling point, then we will understand it is pure. But if it boils at lower than its melting point, we will understand it is impure. Well, then a very important process that is called chromatography, which is including our O-level syllabus. Here, the purity and impurity can be understandable by observing the spots it will give. We later on in our later slides, we will explain how the chromatography process will be run. Without the proper explanation, you will not understand it properly. So I will discuss it in the later part of this video. Well, so now the question comes, if once we understand we have to separate a particular substance from a mixture, then how will we separate it? There are several separation techniques, for example, filtration, then for example, distillation, evaporation. So there are lots of processes. So which process we will use for to separate a particular substance from a mixture depends on two properties of that mixture. First property is the property of the mixture, and second thing we have to consider which substance we want to separate from that mixture. Suppose if we have been given a mixture of solution, salt water solution, so we want to separate salt or we want to separate the solvent part. That means the liquid part. It depends the technique of separation technique we will use. It depends on which type of substance we are most interested in, which type of substance we want to separate. So these two things we have to consider before using the separation method. Okay, gradually, I hopefully you will understand it, everything. Let me explain the process first. Here are some example and the techniques are given. For example, if a mixture contains two different types of solids, then in many times we use a method where the properties of the differences of the two substances. For example, in a mixture of two solids, if it contains a magnetic substance, then easily we can separate that magnetic substance by using a magnet. Okay. Also, similarly, we can separate we can use different method based on its density. Okay. So, and also sublimation, whether if any sublime substance is available in a mixture, then we can evaporate it to get the sublime at first, because only the sublime will be evaporated, and rest of the things will be converted into liquid at first, from solid to liquid and liquid to gas. But the sublime will be directly converted from solid to gas. So using the differences of the components of the mixture, we can use the technique. Then we can also use, if a substance, if a mixture contain any solid particle which is insoluble in water or insoluble in a liquid, then we can easily separate the solid particles by using a strainer. That means we can use a filter paper to separate the very fine particles from the mixture. Okay, so we have the property of the mixture is very important. If the particle is insoluble, and it actually the mixture is called filtration, we can use this technique of filtration. Then if the opposite things happen, suppose not opposite, sorry, the next step is if the solid particles of a mixture is with coarser size, in that case, we don't need to do the filtration, rather we can use decantation process. Decantation is the process where we can slant the container to separate it from the another component. Okay. uh, Two or more of the immiscible liquids can be separated. For example, if they're immiscible, in that case, we can use the decantation process. Later on, I will explain it by using picture, then you will understand it better. Solution of solid in liquid. Here, it is called solution. That means the solid particle is totally disappeared in the liquid part. That means it is totally dissolved in the liquid. For example, sodium chloride and water. It is a solution because here the sodium chloride is completely dissolved in water. That means it is disappeared whenever it is dissolved it is taken in water. So in that case, the water can be seen. How we can separate the solid part? Here we can do with this process, we can use a process which is called crystallization. Here we can convert the insoluble solid into a crystal. The technique is, I will explain it in my later slides how we can do it. It is we actually first we evaporate a part of the solution, and then if we cool it, the crystals starts forming. Then by filtration, we can separate the solid part from the solution. And if we want to separate the liquid part, in that case, we have to use distillation process. It is the combination of evaporation and condensation. Uh, Suppose if a mixture contains alcohol and water, in that case, how we can separate the alcohol part, or if it is, suppose if it is a solution of sodium chloride and water, then how we can separate the water part, liquid part. First we can evaporate it, and then you can condense it, and by this process the liquid part will be separated, which is called distillation. Later on I will explain it to students. You will understand all this process whenever I will show it by showing the pictures. I will give the picturized explanation of all these processes. And there is also fractional distillation. This process will be used when the components have a very close boiling points. For example, alcohol and water. Here the boiling points of water is 100, but the boiling point of alcohol is 78 degrees Celsius. So we can use crystallization process. Then the different fraction can be separated by this process. Here the separate fractional column is used. And at the different heights of the columns, different components will be separated. For example, more examples can be given. For example, we know that crude oil contains different fractions of fuels like petrol, diesel. So, natural petrol, diesel, kerosene, and all. So, those different parts have very close boiling point difference. In that case, we can use fractional distillation to separate the different components from the mixture. And chromatography, as I have mentioned, the chromatography will be explained in the latter part of this video. Okay, students, let me change the slide now. Well, now look at this picture here. Suppose you have got a mixture of sulfur and iron. So how we can separate it? It's a very easy technique to separate the components from this mixture. If you use a magnetic substance, if you use a magnet, you know that iron is a magnetic substance. And whenever you bring a magnet close to the mixture, all the iron particles will be attracted towards it and it will be separated by this process. Here in the picture, I think you will understand. Okay, let me change the slide. I hope you understood, students, and if you have any confusion, please let me know. If any solution contain any dissolved substance like sodium chloride and water, here no, sorry. If any if any substance, if a suspension, that means suspension is that one where the mixture contain any insoluble particle, not sodium chloride. Insoluble particles like lead chloride are insoluble in water, or sand is also insoluble in water. So if I got a mixture like this, then you can use the filtration process. Here, filter paper contains very tiny holes, and through that holes water will be separated from the insoluble part. That means from lead bromide, on the solid part which is insoluble in water, that will be stuck with the filter paper, and rest of the part will be separated and it will be deposited at the bottom of the conical flask. So using the same picture, you can separate the insoluble particles from the soluble particles from a solution. Students, I hope you understood. Let me change the slide. Okay. And like in the previous process, we have seen that the particles are very fine particles. In that case, we are bound to use the filter paper. But if the particles are a bit coarser, that means it contains mud or suppose sand, then you can see that it looks a bit turbid in the left side one, because it is very turbid because of having some other particles like coarser particles like mud or sand like this. But if we keep the suspension for a longer time without any kind of touch, then all the marks and undesirable particles will be deposited at the bottom. And by slanting it, we can separate the solution, and the sand will be available in the measuring cylinder. Okay, so I hope you understand. So here, rather than using filtration process, we can use this decantation process. This is called decantation. Let me change the slide now. Well, sometimes a mixture contains substances of two different components of two different densities. For example, oil and water, they have completely different density, and that sometimes their colors are also different. So here, they can be understandable by their colors. So we can use separating funnel to separate them. Separating funnel has a key in the lower part. If we open the key, then the lower part of the first components of the mixture is lower part, so it will be separated once we open the key. And whenever all the components from this type of mixture will be separated, then we can close the key again. So by this process, we can separate components of two different fractions by fractional distillation. Here, I have given the example of oil and water. I hope you understood. Let me change the slide now. This is a crystallization process where we separate components from from a solution. For example, if the one component is totally dissolved in the water, for example, sodium chloride and copper sulfate or sodium chloride in water. Here, the salts are dissolvable, completely disappeared in the solution. We cannot see it. It is completely miscible. So how we can separate it? We cannot do the filtration, because if we do the filtration, all the solid particle will pass through the holes, because these are very fine and totally dissolvable and dissolved in water. So in that case, first we have to make sure that the dissolved particles will be converted into crystal, and then in that stage it will not be disappeared. Then we can, by filtration, we can separate the process. So first we have to convert the dissolved particles into a insoluble particle. So here what we have seen, according to the figure, we have to take in the solution into on a tripod stand, and we can heat it. Some part of the water will be evaporated and the solution will be a bit concentrated. Then if we keep it for cooling, then the crystals which are completely um, disappeared, that will be transformed into appeared particles, and it will start becoming crystals. So the undesirable the particles which are disappeared in the solution, that will be gradually appeared here, and in the last process we can use filtration to separate the particles. So this process is actually called crystallization. By this process, the dissolved particles like sodium chloride or copper sulfur in water can be separated from the solution. And we can use alternative process of the previous technique, and later on forming into crystals. If we evaporate all the water part from the solution, only the salt part will be available. Only the crystal will be available, and rest of the part, that means the water part, liquid part, will be evaporated. So that by this process, we can also separate the dissolved solid part from the solution. So it is the alternative process of the previous one. That means crystallization and evaporation to dryness. We are doing for the same purpose, but the techniques are a bit different. In the previous two techniques, we have separated the solid part from the solution. But if we have to separate the liquid part, then what will we do? Here you can see that in the figure, we have used distillation process to separate the liquid part from the mixture. That means if we want to separate water from the solution of salt and water, then we can use this one. It is called distillation. Distillation actually is a combination of um, mm, evaporation and condensation. First, we will evaporate a solution, then suppose the water from salt solution will be evaporated at 100 degrees Celsius. All the water will be evaporated and it will be injected inside the condenser. And inside the condenser, the water will be transformed into liquid water. Gaseous water will be transformed into liquid water, and it will be collected from the another end of these apparatuses. Okay, so by this process, the distillation process will be done, and we can separate mixture of water part from a solution. But the latter part was used to separate the solid part. I hope you understood. In the condensation process, sometimes it is a bit complex, because we have to use fractionating column to separate different components from a mixture where the fractions have very close boiling point. For example, alcohol and water. Here, alcohol will boil at 78 degrees Celsius and water will boil at 100 degrees Celsius. So their boiling points are closer. In that case, we have to use a fractionating column. Inside the fractionating column, the columns it contains different columns at different heights. So at different heights, different components will be separated. So here also it is also called distillation, but it is as the fractional columns are used additionally, so it is called fractional distillation. The very important use of fractional distillation is to separate different component, different fractions from a crude oil. You know that crude oil contains petrol, diesel, natural gas, and all. So how we can separate different fractions from a crude oil? So crude oil can be used. A fractional distillation will be used in case of separating different types of fuels from a crude oil. I hope you understood. So, yeah, petrol, diesel, and kerosene, etc., will be separated by using fractional distillation. Let me change the slide, students. So this is, as I have mentioned that in the later part of this video, I will explain the chromatography process. Chromatography is the process which will separate the components from sample, and it will also help to identify which components are available there, and also it will help to determine whether the mixture is pure or impure. This process is used for many cases. Suppose the sportsmen who are participating in the sports, whether they have taken any illegal drugs or not, that can be understandable by this purification, the chromatography process, by testing their urine. By testing our blood, we can also understand which components are available into our blood and all. So let me try to understand the process. Here, basically, in a chromatography process, we will use a solvent which will dissolve the mixture which we are going to test. Okay, suppose if I want to test urine, then the urine must have to be dissolved in that particular solvent. That type of solvent needs to be used. And also, the very importantly, we have to use paper, a special type of paper which is called paper chromatography paper. So that type of paper will be used to understand the chromatography process. So let me explain how it works. Well, suppose this type of paper will be used, and here upper part and lower part will be of the water will be open, and you have seen a solvent. We are told that we have to use a solvent. This solvent should have the property of dissolving the mixture which we are going to test. Here you can see that we have to test a particular mixture that is taken on the pencil line. We need to use a pencil as well, and the pencil mark will be given, and we have to ensure that the solvent which we are going to use, that should be under the pencil line. And on the pencil line, we have to use the just one drop of that mixture which we are going to test. Suppose the mixture is the mixture which we are going to test, that one must be soluble in the solvent. Here, the solvent is taken ethanol, because the ethanol is capable to dissolve that mixture. Okay. You can see that whenever we will arrange everything like this way, according to the figure, the solvent, whenever the solvent and the paper chromatography will be arranged according to the figure, then the solvent will start climbing up on the paper. And you can see the dot line. It shows that the solvent will climb up to this length, that dot up to this dot line length. And whenever the solvent will climb up, then the mixture will be dissolved in it, and the mixture is will give two spots on the paper chromatography, yellow spot and blue spot. I hope you have seen it. So two spots it is giving. It shows that the mixture contains two different components. Type of Everything is explained here, what is going on. First, the solvent will climb up when everything will be arranged according to the paper. With that paper, the spot will also start climbing, and it will be split into two spots. As the solution solvent which we have taken here, it is more soluble in the mixture, so it will climb more than the spots. Let me change the slide. Just go through the, sorry, yes, just go through the explanations given here. Then I will change the slide and then I will explain so that it will be clear to you. Okay, if the mixture gives only one spot, it means that it is totally pure. If it gives two spots, it means that it contains two different types of components. So it gives in the figure given here, as it gives just one spot on the paper chromatography, so it indicates that it contains only, it is totally pure substance. No other components are available in the mixture. I hope you understood. Here also we have to find out RF value. RF value is the value which is the ratio of substance available in the mixture. The substance traveled by the distance traveled by the substance and the distance traveled by the solvent front. So you can see in the picture that the mixture has a spot, and we can measure the distance from that spot to the pencil line. That is actually the distance traveled by the solvent, distance traveled by the substance. And then we have also got a distance from the solvent front and to the solvent front from the pencil line. That is the distance traveled by the solvent. So RF value distance moved by the substance divided by distance moved by the solvent front. Okay. So here distance traveled by the solvent is a, for a particular substance, this RF value will be constant. So after calculate or after measuring the RF value from the picture, we can try to match it with the table. A particular table is formed to find out, it will be given to find out the RF value, the components of different RF values. Okay, every different components have different RF values. So first we have to make sure that we have find out, we have measured the RF value by using the formula, that is distance moved by the substance divided by distance moved by the solvent front. I'm changing the slide now. Just go through it. Here the temperature and solvent, this should be constant for a particular RF value given. Here the practical example of find out the use of chromatography technique. Here you can see that uh, C is a banned substance which should not be consumed by our body. So, using, if the C is available, C contains two different spots. That means if two different spots are available, in the mixture that is not good for our health. So after the chromatography, it is seen that X is the mixture which we are going to test, and here A, B, D does not contain any A, B, and sorry, let me check the previous slide. Four band dyes are here. Four band dyes are in A, B, and C and D. You should understand X contains any of these four band dyes. It is not safe to our consume. A, B, C, and D, these are band dyes. So you can see that whenever if you analyze A, we got a spot. If you analyze B, we got another two spots. If you analyze C, we got two spots. And if you analyze D, we got a spot. So here identical dyes produce spots at the same height. Same X does not contain the band dyes A, B, and D. Any of these spots of X does not match with A, B, and D. But however, X contains the band dyes C. You can see, but X contains band dyes C. How we understand? You can look at the C is giving two spots, and two spots of X contains both the two spots of C. That means it contains a band dyes of C. That means we should not supposed to consume that specific food because of having band dyes like C. If these two spots are not available in X, that means the uh, green type spot and the if the light purple type spot, that if these two spots are not available in X, then the text can be consumed. Otherwise, as it contains band dyes like C, we cannot consume or because it won't be good for our health. Here another example. Sample X is a mixture of three dyes. You can see by three different colors, you can see that three spots we got from X. That means three spots are there. Both dyes B and C are mixture of two different. Here you can see that if we analyze A, it is only one spot there. That means A is pure. And if we analyze D, also we got one spot that is also pure. Both B and dye C are mixture of two different dyes. Okay, B and C contains two different dyes. That means it's a mixture. So it is understandable the text contains both one spot of B and X also contains a spot of C and also of B. I hope you understood. So sometimes the spots are invisible. In that case, we have to use a locating agent. A special type of substance are there, which if we spray it on the paper, then the unseen spots can be seen. So it is called locating agents. Thank you very much, students. Hopefully you understood it, and if you do not understand, please let me know it. Thank you. Thank you.